Okay, let's take a look at getting materials configured in Blender. So Blender has a couple ways you can do this. They have a materials shading system. There's a lot of different surface shaders to choose from. And then we can also get some textures from the internet to make realistic looking materials. So let's start by just taking a look at what I have set up already. This is a Suzanne monkey mesh. And if we go to my modifiers, I just have a subdivision surface modifier, and I right-clicked and did shade smooth, and that's so that we can just preview our materials as we add them. Let's go down to the material tab, and you'll see that there's nothing here in the materials. If I click on new, it'll create a material, and it looks exactly the same as the default material. So if I double click, we can change this to monkey, and that way I can find this material later. If I click on this beach ball looking thing, we can see that I have this new material called monkey in that list. I can switch between the materials with this selected by clicking on them. The reason that that's important to note is because you can have more than one material on an object. I can click on the plus button, I can add 2 more slots. I can go ahead and add that original default material, and I can add this second material. I actually have 3 materials, and just to show you what's happening, I'm going to change some color here. So if I open up the surface drop down, I'm going to make this red. Under this material, I'm going to choose blue, and on this one I'll pick green. So what you're seeing is that it's not changing from red. Even if we take this and move it up, it's not changing. So these arrows will change the order, but what's happening is that essentially red, this monkey material, is assigned to all the faces. So if I click on tab, if I select a bunch of random faces, select a different material and click assign, now you can see it's assigned that blue material to those faces. I'll do that with green as well. I'll assign those, and now I'm getting different materials on different parts of our mesh. This is not really a good way if you're trying to get texture and to color in certain regions. You do want to stick with one material unless the material properties are very different. But typically adding faces, materials to specific faces isn't going to be a very easy workflow. So for that reason, I tend to not do that unless there's a specific use case. So we're going to stick with this one. Let's go ahead and head to our shading tab, and you'll see that we have that principled BSDF material that we created. This is going to allow us to do physically based rendering. Eevee is more like a game engine approximation of physically based materials. It does a pretty good job, especially with the new version of Blender. And if you have a computer that's new and supports ray tracing, you can turn on ray tracing. However, if we go to cycles, that's going to be the render engine that's going to give you the best render result. I'm going to switch to GPU compute so it just goes a little bit faster for the demo here. First thing I want to do is just move where our light is. Okay, so here is the default material settings. I did choose red. I'm going to put this, maybe I don't like looking at red, so I'm going to choose blue. If we want to make this look like shiny plastic, I can just take this roughness slider and move it pretty far down. And now you can see that it's simulating a smooth surface. And so these specular highlights are really sharp and really apparent. If I drag roughness all the way to 1, it then diffuses those specular highlights across the surface and scatters them as if it was like really rough rubber or some other material. By default, it's about 0.5, somewhere in between. It's kind of like a dull plastic. So there are a couple different ways to think about how your materials behave. Essentially, your principled shader is controlling how light reflects off of your geometry. That's all it's doing. It's also simulating internal light bounces and in some cases refraction. but I'll go through those in a second. So if you want to make it metal, you just take the metallic slider and go to 1. There is no such thing as a half metallic thing or a half metallic object. You may have an object that has dirt on it, and therefore there might be a metallic map that makes some parts more metallic than other parts. But in the real world, we have things that are metallic or not. And non-metallic objects are called dielectric materials. So this is with the metallic slider turned to 1, you'll see our reflection colors are a little bit different now. What we can do is come down to coat. And if I want to make this look like it's glossy car paint, I can take the weight of coat and bring that up. And we can take roughness. Let's bring roughness down. And let's see what else we can do. Let's maybe move this light source closer. Here we go. All right, so coat is going to be adding a thin coat of almost like gloss to the object. We can take the roughness down. We can adjust the index of refraction. So anyway, that's kind of how you can start controlling what the surface looks like. Transmission is going to essentially allow this to refract light as if it were glass. To get that to work, we have to do a couple things. We're going to turn transmission weight to 1. We're going to turn metallic to 0. Roughness is going to come way down. And what you'll find is it doesn't quite look right. And that's because glass refracts light. You need something to be refracted. So if I was to take this cube and put it behind it, right now the cube is being refracted as we look through this material as if it were glass. And if we were to hide this, all of a sudden it's less apparent that this is glass. So you really need other objects to reflect into this glass object to be convincing. If I was to take this and make it lighter, you'll see we have pretty high refraction, and different materials are going to refract differently. I think water might be, I forget, I think it's something like 1.35. There's a table that you can look up that will show you what water is. But water refracts just like glass does. Okay, so if you want to make this refract like instead of being a solid glass object, you want it to be more like a shell, we can solidify this object and basically add a thin shell of geometry on the inside. So you can actually see that getting added a little bit there. And now what's going to happen is it's going to be treating the reflections and refractions like a shell of glass, like a cup. So if we want to just take a look at what that might look like with an easier example. Let's go ahead and make a glass here. Oh, I put that edge loop in the wrong place. There we go. Okay, let's shade that smooth, and I will add a subdiv surface. Let's hide our monkey and add some more divisions. Okay, I'm going to inset this so we get a bit less artifacting happening. Okay, so not the best glass in the world, but what we can do is add that material that we created. So it's just called monkey for now. So what we can see is we're getting this refraction happening. So one thing to keep in mind, as the light comes through, it's going to be essentially hitting the surface, bouncing on the inside of the other wall of this glass, and then coming through this wall and then through another one. Essentially, you have many light bounces happening. So if you don't increase the light path quality or the amount of bounces to be enough, what you'll find is you start getting black areas. But this is how you can make a glass really quickly. And actually, even though these are essentially smoothing mistakes that I would have likely wanted to fix, I quite like them on this glass because it gives it a more realistic kind of ripply look. But that's how easy it is to make a glass using the principled shader here. All I did was turn on transmission and turn roughness down. So 2 settings, which is pretty easy to do here. Okay, I'm gonna go ahead and delete that. Let's bring our Suzanne back into view. Okay, the only other one I will talk about right now is, well, one of them is Subsurface. So Subsurface is going to be kind of like what skin does with light. If we turn on the weight of 1, let's turn roughness to 1, and let's just take a look at what we have. Transmission, we need to reduce that to 0. Okay, let's take this light and put it behind our monkey head. Okay, and so what you're going to see happen when I turn this scale up is it will start to allow the light to bounce internally within this mesh. I think my solidify is interfering, so let me go ahead and turn that off. Yeah, so here we go. Let's turn this back down a little bit. What you're seeing is this light bouncing inside and then coming through as if it was something like skin or a leaf. Anything organic typically will allow some light in and bounce that light internally. If we want to make it look less like skin, we would turn off maybe this top radius. So this is really a stand-in for RGB. So it's the red channel, the green channel, and the blue channel. So if I turn this to 0 and turn the blue channel to 1, now you're seeing this blue light come through instead of the red. And then you can, of course, do combinations of these settings to dial in the light that comes through. The surface itself will also play a role in the light color that gets bounced out of the surface. So it's going to be a kind of balance between the RGB settings and this scale multiplier here. But the ears are the thinnest part, so naturally that is where the most light is bouncing through. Okay. What if we have another object? Let me add a sphere here. And let's say this mesh object illuminates. So what we can do is add a new principled BSDF. And to make that illuminate, we go down to emission and we turn the strength up. So I can make this something like 10. Let me go ahead and hide our light here. So we're just getting light from our emission shader. Okay. We can color the light. As you increase the strength, this mesh is going to get closer and closer to white. The light that it does reflect and emit is going to have that color though. So just keep in mind, you can paint with light just like you would color the other types of lights. So if you were to add a point, sun, spot, or area light, you can choose the color as well. But in this case, this is coming from an object that has the shape of our mesh, which is nice. So if I want to have something practical in my scene that creates light, that's how I would do that. There is a material that I could use called Emission. So if we didn't want to use the principled, we could simply get the Emission material, and that's going to do the same thing. The difference is there are fewer settings to have to contend with on the principled, but the principled is our multi-tool material. We can kind of do anything we want with it. Okay, I'm not going to go over the other ones or the other settings right now, but what I want to do is talk about how we can start getting materials to have realistic texture on them. Let me go ahead and hide this. Okay. So what we'll do is just add, let's say, a plane. And if I want to make this look like sand or grass, what I can do is go to a website like ambientcg.com, and I can find material that I want. Let's say I want to make that a floor. Let's say I like these floorboards here. I can go ahead and click on that, and we have a bunch of options to download. You are fine to get JPEG or PNG. JPEG is fine. For most of my uses, I'm going to use 2K here. 4K and 8K are going to be much higher res. So if you're really up close to an object, you want to use this higher resolution, but your file sizes will start to get really big. So I'm going to go ahead and go download this 2K texture pack. And what we can do is open up that texture pack. I'm going to drop it into this folder here. Okay, and here we are. So that texture pack is going to have a bunch of things in it. It's going to have this color, ambient occlusion, displacement, metalness. So there's a couple nails, I guess, on the floorboards, and these normal maps, and it looks like a roughness map. And these other ones we don't really need to worry about. Okay. So let's go ahead and look at how we can add those. So create a new material and go up to Edit, Preferences. Let's go to Add-ons, and I want to turn on Node Wrangler. I already have Node Wrangler turned on. If you don't, enable that here. Close out Preferences. With Principled selected, do Shift W, and that will bring up the Node Wrangler menu, and do Add Principled Setup. Okay, now we're going to go into our texture pack that we just downloaded, and I'm going to select roughness, normal GL, metalness, displacement, color, and ambient occlusion. I don't need the other normal map, and I don't need these other files. Okay, now what that does is it automatically adds image nodes. It automatically plugs those image nodes into the correct place in our principled BSDF, creates a displacement node from our displacement image, and plugs that into the material output displacement slot. All of them are controlled by this texture coordinate and mapping nodes, which allow us to change things like rotation. We can change location. Okay, Blender crashed, so I had to set this back up. The autosave didn't work this time. I'm going to go ahead and save this. Okay, so with those images added, we can make a realistic looking wood texture. We're not done. There's a few things we have to do. Number one, this displacement node doesn't really do anything out of the box. That's because if we select our material output, go over to materials, make sure we're in cycles. We scroll down to settings and open that. We'll see that only bump is enabled. We actually have to turn on displacement and bump to get this displacement working. It might get kind of wild when you do this because the setting can be too high by default. I'd like to put that on 0.1. We need to add additional vertices. A displacement will literally move those vertices in 3D space. We don't really have any to move. So what we need to do is add extra detail. There's a couple ways we can do that. I can choose the feature set experimental, and I can go down to the modifiers, and I can generate subdivision surface. Let's do simple, and I can do adaptive subdivision. You're not really going to see that here, but essentially whenever we render this, I think we need a light in our scene. Let's go ahead and add a light. There we go. All right. So this is showing you kind of what would happen if we leave those settings like scale at 0.1, using this adaptive subdivision. Again, that it only exists in experimental. And the way it works is as the object is closer to the camera, it adds more subdivisions, and as it goes farther away in space, it adds fewer subdivisions. If this doesn't work for you, essentially what you can do is come to supported, leave that on, and then start adding subdivisions. I'll probably apply this. Let's add that again. So you can see as we add them, it's starting to take these polygons that are roughly that size and move them up and down in space. Unfortunately, to get this to work, we need a crazy amount. So look at how many we have right now. So I'm going to right click and do shade smooth, and that's going to make our surface look a lot nicer. 0.1 is still way too big, so I'm going to go ahead and drag this down to be, I guess 0.02 looks pretty good. Okay, so that's 0.02. Going to add a background in. Okay, so now you can see that we are getting really nice displacement. We're also getting really good color, and all the other maps are working as they should. Just to show you how each one is configured, ambient occlusion, I'll probably change that to be sRGB. I want to mix that into my base color. So I'm going to go ahead and add a mix color node. And then let's put the factor up and put multiply on. Okay, so you can see it just adds a little bit more, very faint amount of shadow information to make it look a little nicer or have more contrast. the principled shader doesn't have an ambient occlusion slot, so you have to mix it into the base color. You can do all sorts of things with ambient occlusion, but in this case we're just going to use it very simply, mixing it. The base color is pretty straightforward. That is the flat unlit color of the object. The metallic map will tell you what parts of your object are metal or dielectric. It is non-color, color space. Okay, so sRGB is the default when you add an image node. Non-color basically says this isn't contributing color information to the surface, it's contributing surface configuration. So the roughness is basically saying I'm rough here, or I'm not rough, or I'm shiny, and that's not really color. So it's more like utility. The reason that you don't want it to be sRGB is because Blender has color management profiles, and so you can actually change the colors globally to have more contrast and things like that. But you don't want that to change the physical material properties. So you don't want to color manage these particular image textures. Same with roughness and displacement and normal. So I do want to show you what normal does. Just show you what this looks like. We're going to plug normal directly into the surface. So this is what the normal map looks like. It is being lit, I think. But effectively, this will use information to, like just flat pixel information to tell the light to bounce in a certain direction. So you can cast shadows, for instance, just to prove that this isn't displacement. I'm going to unplug that. I'm going to bring this closer to the surface so we can see. So as I move this, you can see it's casting shadows and catching highlights, even though our plane is perfectly flat. It's very high resolution, but it's perfectly flat. That's the normal map working for us. So now I can plug our displacement back in and get that extra detail. That's pretty much how it works. And this is the same theory behind how it works in video game engines as well. And this is what enables a video game engine to simulate something realistic, but 60 frames or more per second. Okay. The only other thing I think I'm going to show is lighting options. So if you have an environment, I'm going to set one up quickly. And you need to light your environment to be realistic. There we go. Okay, so I have a couple things here on this plane. To create realistic outdoor lighting, what we would do is go to the shading tab where it says object, change that to world. And this is the same as the background tab here under world settings on the right. This is essentially ambient light that's being contributed. So even though there's no light source turned on right now, we still can see a little bit of something. And that's the ambient light. That's kind of global. If I was to turn this all the way to black, then it would be like outer space minus the stars. If I turn this to white, we would have a ton of ambient light illuminating our scene. So I'm going to undo this, put it back to the default gray, and we're going to add a couple nodes. So the first node we can add to simulate an outdoor scene is to add a sky texture node that's built into Blender. I can connect that to color, and then voila, we have a sun and sky. We can change the rotation of the sun to change the direction of the shadows. We can change the elevation of the sun to change how those shadows are being cast. So if we have the sun going down, these are going to be really long shadows. The light is going to change as well, from blue light at midday to warm light in the evening. We can turn off the sun disk. What that will do is it'll make it a lot more evenly lit and the shadows will be a lot softer. I find that the sun is super intense by default. If you want to keep the sun disk and just soften these shadows, you can change the size of the sun and just blend those out. It's not very realistic, but it might look nicer. Okay, so that's the sky texture. There are different types of sky textures you can use. Go ahead and this one. So you kind of use this normal map tool to direct the light with this shader. So I actually like the default Nishita version. Okay, so that's the sky texture. I'm going to unhook that. Now we're going to add an environment texture. So if I do environment texture, it looks like an image texture. It's a little bit different. This is going to map it to the world using equirectangular mapping, and that's typically what your images are going to come in as. If we go back to our Ambient CG website, there are HDRIs at the top. You can go and grab any of these images. Let me just click on this one. I'll download this 2K version of this, what looks like a farm field of some kind. If I was to open this up in Photoshop, just want to show you how this HDRI works so that you can understand why it's so important to use these to light your scene in Blender. Okay, so you see it doesn't look quite as good as the preview, right? And that's because we can't see all of the color information this has within it at once. This image is a 32-bit image. Monitors are usually not 32 bits. They're 8 bits. HDR TVs and computer monitors can see more color than they ever have, but you still can't render an image like this. There's just too much color information. Let me see if we can adjust the exposure to show you the benefit. So if we take that exposure down, instead of this white just getting darker, what we see is all of this detail that we didn't see previously that exists, all the way down to that little sun disk. We get all of this cloud information. Even though the exposure is set here normally, we can't see that. And that's because we have to bracket way down. And it's the same on the other end of the spectrum. Maybe not so much in this image. Sorry, I'm using the scroll wheel here because I'm used to Blender now. Let me zoom in. So I'm going to try to find a shadow. So if we bring our exposure up, there aren't a lot of dark shadows, but effectively you have the same amount of information in the shadows as you have in the highlights. So if I bring this, it looks like this isn't the best image for dark areas, but that's how that works. And this is going to contribute a lot better light on your scene. So let's go ahead and jump into Blender and open that image up, or I'll probably grab a different image here. I have a couple that I've already downloaded. And so let's plug that in. And now what we have, and you can kind of see it wrapped around the scene like a sphere in the background. Now we have that image contributing light to our objects. Okay, and what we can do, if we don't want to see that background, we can go down to Film, click on Transparent, and now we don't have to look at it. The other thing we can do are, maybe build some walls. So we can build a wall there. And then when we look through I have to add a camera. But we can look through our camera. Go ahead and lock that. And just make sure that we're not seeing either transparent pixels or have a plan for compositing something behind it. And that's totally fine as well. But this might not be bright enough. So what you might want to do is kick up the strength a little bit, maybe 2 or 1.25, something like that. It's not a great scene because there's not a lot of detail happening. Maybe I'll bring that floor back in. Okay. So this is the floor rendered with outdoor lighting. Okay, so those are the two ways you can create a global light that's supposed to be mimicking an outdoor scene. An HDRI image is typically an EXR format. There is an HDR format as well. These images are created outside using special camera equipment. When they're filming a live action movie that they later know they want to have 3D composited into, they will actually create one of these and give that to the visual effects artists so they can light their scene with the same lighting that they had on set. Okay, that is it for materials and lighting.